Today, I'd like to talk to you about creativity. We're now starting the second half of the course, and each one of you will be coming up with a variety of creative ideas for a new product, and you'll then be selecting one of these ideas and developing it further as a concept, looking at the detailed design, looking at advantages, disadvantages of different technical approaches, different implementation ideas, looking at a market, how the product can be advertised, that kind of thing. But before you can do that, you need to come up with lots of creative ideas. And I'll say at the beginning, it's a little paradoxical that I'm sitting here trying to help you come up with creative ideas, because the most important piece of advice I'd give you is there are no rules. Whatever works for you, do it. You don't have to follow someone else's creative structure or creative suggestions. If you find that you have your best ideas when you're lying in a rowing boat, drinking brandy and listening to Stevie Wonder, do it. If you find your most thoughtful, most creative when you ride round and round on the Circle Line of the London Underground, do it. And pursue your passions. So you've got some time this week when you're doing this assignment just to go and read up on some completely new topic, something that interests you. Maybe it's gas turbine powered cars. There's quite a lot of interesting information on that. If you want to look at gas turbine powered cars, coal dust powered cars, all sorts of cars with unusual power sources. Or maybe you're interested in, say, the history of air conditioning, how it developed. Maybe this could give you a great new idea for a cheap air conditioner for a developing country. Maybe you're interested in food, in cooking. Read about cooking. Think about what's missing from your own kitchen, which you would love to have as a device to help you cook. Even if it's a device that perhaps makes it, it takes away some of the limitations in the kitchen. Not that it necessarily imposes a rigid structure on the way that you cook, but it gives you more opportunity, more options. And this stage of the process, if you like, it's a bit like mining. Perhaps you want to make some pottery, and to start with you mine clay out of the ground, and you mine as much as you can, and then later you take the clay and you sort it. You say, well, you sort it according to the color and the consistency and the properties, and then you mix it, you get it into the right form, the right mixture to make your pottery out of it. Then you shape it into a pot, and then you fire it and you glaze it and you end up with your finished pot. And towards the end of that process, you're following something quite structured, quite a structured method. When it comes to the firing and the glazing, they have to be done at the right temperatures and for the right durations. And at the beginning, well, you can take whatever kind of clay you want. You can make it into whatever shape you want. You can decorate it in whatever way you want. And I'd like to talk to you a little more about the activity of idea generation, because when you're coming up with a new idea for a conceptual design or for a real design where you're going to construct a prototype, then you see a similar situation. Here's a spectrum, and the spectrum runs from creativity to rules and structure. Now, rules and structure will not help you to come up with any new ideas. They are, in fact, leading you in exactly the opposite direction, because rules are based on what has worked in the past. And you want something that's completely new, so you have to get away from things that have worked in the past. You need something that's inspired by anything, or everything, or nothing. And in order to do that, you need a certain chaos. You need to inject some chaos into your life, into your thinking to get there. And then in the design process, you want to slowly remove some of this chaos as your ideas crystallize and become clearer, and introduce some structure. Otherwise, later in the design process, you'll find that you're making last-minute design changes, you're having to make components a second time over, and you're wasting a lot of money. So, to give you a few ideas for how you can inject some creative chaos into your thinking, I'd like to give you a few examples of famous inventors. People have come up with some pretty way out ideas. And these are people you can also research on the internet. You can take a look at their work and the things they've invented in your own time. The first I'll mention is Claude Niepce. Claude Niepce was a Frenchman, I think about 1700, who invented the pyrophore. The pyrophore was one of the very first working internal combustion engines. And the amazing thing about it was that it was powered by moss spores. So someone had the idea of drying moss spores and taking these and setting fire to them. And they discovered that these burnt very violently because they have a large surface area and they're made out of combustible plant material. And Claude Niepce had the idea that you could take these moss spores and you could put them in an iron cylinder with a piston and use them to drive an engine, which seems completely crazy, but actually worked and created one of the very first functional engines. The second I'll mention is Frank Whittle. Frank Whittle is more likely to be familiar to you. Frank Whittle was an Englishman who was in the Royal Air Force, and he's generally credited with the invention of the modern jet engine. And Frank Whittle, when he was in the Air Force, nearly quit because he felt that the discipline there that was imposed on apprentices, he was an apprentice, and was far too strict, far too limiting. And he then nearly got expelled from the Air Force for aerobatics and low flying in his plane. And he returned to an old idea of taking a piston engine and squirting extra kerosene into the exhaust to create a flamethrower and give it some extra thrust, which sort of worked, but it wasn't very efficient. And he then had the idea of, well, maybe we can replace the piston engine, which creates the initial pressure difference to drive the flamethrower, with something smaller and lighter. And then he thought, well, something like a turbine, something like a development on a windmill. And turbines already existed, steam turbines and things like that. I think at that stage the gas turbine had also been invented. But he then thought, well, let's inject extra fuel into the exhaust of a turbine and see if we can use it to create a lightweight engine that produces lots of thrust. It was eventually successful, and there's a funny story that Frank Whittle had to show great determination. He had to put a lot of effort into this because a lot of people were telling him, Frank, it's never going to work. And eventually he built a prototype. It seemed to work okay on the ground, so he put it into a plane, and the test plane flew perfectly. And his formerly skeptical colleagues looked at him and smiled and said, Frank, it flies. He looks at them and says, it was bloody well designed to, wasn't it? The last one I'll mention is James Dyson. Now, you know the name Dyson from Dyson vacuum cleaners? James Dyson had the idea of the vacuum cleaner from a device that he invented for cleaning up the workshop where he was applying powder coat to one of his previous inventions, a wheelbarrow with a ball-shaped wheel. And he found that paper filters or felt filters were not working very effectively, and he saw that there was a device at a sawmill used for gathering the sawdust. So one night, he climbed over the fence into the sawmill, climbed up onto the roof with a tape measure, measured the device, which was a cyclone, made some sketches, and then the very next day, on no sleep, went back to his factory and together with some colleagues, welded together a prototype. Over the years, he then had the idea to put it in an even smaller form into a vacuum cleaner, and about 5,000 prototypes later, had something that works extremely well. Key here is determination. I'll come back to that. This stage, I'd like to present you with a few motivational quotes. Thomas Edison, who was the father of power generation and distribution in the United States, came up with a great deal of motivational quotes about ideas and creativity. First one I've got here is, to invent, you need a good imagination and a pile of junk. Now the pile of junk here, it represents this chaos that you're trying to bring into your creative process, that you're trying to bring into your life. Now if you have a pile of junk, you can screw it together, you can solder it together, you can build something out of odds and ends and see if it works. And if you haven't got any ideas, you can take it all apart. You can see how someone else built things, and maybe that'll give you new ideas. Another Thomas Edison quote, I haven't failed. I've just found 10,000 ways that won't work. Comes back to the idea that in creativity and invention, you need a great deal of determination. It's an iterative activity. And the last one. The people who are crazy enough to think they can change the world are the ones who do. From Rob Sultanen. Rob Sultanen created the first successful advertisement for the Apple computer in the 1980s. And as they say, the rest is history. I'll upload a sheet to StudIP, which gives you a few more suggestions for how you can generate new ideas. Remember, as I said earlier, it's up to you to go in your own direction, to follow your own interests and passions, and you shouldn't feel constrained by anything I suggest here. The first thing I'll mention is it's essential to have the right attitude. Don't say, I'm going to think about X in this way, and I'm going to follow this method in this book until I get to a solution. You need to be more open-minded than that. You need to look at everything. Be curious. Look everywhere. Look at objects that you've never taken an interest in before. And make sure that you don't develop any tendencies in your mind to always follow the same path. This is why I'm suggesting this week, read about something that interests you. Maybe go to a new place. Maybe have a beer first. One beer at least is great for creativity. Maybe two, probably not three. At that point, maybe the creativity starts to die. And experiment with methods of thinking. These are not rigid methods, these are suggestions, as I said before. But you can look at things like divergent thinking. You can look this up on the internet. Divergent thinking poses a broad question and stimulates the imagination to come up with a wide range of ideas. You can also think about convergent thinking, which is more restrictive, but if you use it as just one tool, then you can still maintain your creativity. Convergent thinking poses a narrow question and then uses logic to try to work your way step by step towards an answer. Lateral thinking is more about thinking about things in crazy ways, in humorous ways. If you say had a device and you couldn't take it apart because some of the screws were seized, then you might say, one person might say, well, get a longer spanner, a longer lever to turn the screw with. But someone else might say, in lateral thinking, let's burn it. Let's see if burning it loosens the screws. Now, that seems like a silly idea because it's going to destroy the product. Depending on the product, it may damage it more or less. But you can then come back to the fact that heating causes expansion, and expansion is likely to loosen the screws. The last thing I'll mention is reverse thinking. Reverse thinking is the idea of looking for bad solutions. Look for things that will be as bad as possible at solving your problem, or at making money, or at helping people. And then look at the opposite. So if you then look at the opposite of your bad idea, it may be that you can come and find a very positive idea. I'd also encourage you to think big, dream. This comes back to the Rob Sultanen quote about changing the world. Have big ideas. Often it's easier to get people to support you, to invest in a big idea, than it is to get them to invest in a little idea. And don't trouble yourself too much with the practicalities. Maybe it doesn't seem feasible right now. It doesn't matter at this stage. Think big and keep it simple. And the last one, put on a different hat. That means think about ideas from someone else's point of view. Maybe think about them from the point of view of a customer. Imagine you are the customer. What would you want? Imagine you are a competitor. Yeah? How would you perhaps find an equivalent product that then circumvents a patent that you've got on your idea? How would you simplify the idea to make it cheaper than the original idea? And in doing that, you may then be able to improve your idea by thinking from the point of view of the customer or from the point of view of a competitor. Your assignment for this week. I'd like you to think up 3 new concepts from your own subject area. So from mechanical engineering or electrical engineering or mechatronics. And I'd like you to sketch, annotate, and explain these in a single PDF document, which you can then send me by email. I don't want to put too many constraints on this. You can sketch them using AutoCAD, you can sketch them using a pencil and photograph them. You can draw cartoons. You can write bullet points, you can write long written descriptions. You don't have to have pictures if you really don't want to, although I'd suggest it's easier if you do. I don't want to put too many constraints on this because I want to bring you back to the point which I explained at the beginning. There are no rules. Thank you. That's all for this week.